स्वरांगी जॉईन झाली आहे का?
I'm there very much, Sukrita.
Yes, sir. Yes. Swarangi.
Yes, ma'am. Am I audible?
Yes, you are.
Yeah, ma'am. Alimi. Yes, sir.
मला ऍक्च्युली मला कळत नाहीये की
Hello everyone.
Swarangi, you,
We are live now.
yes, Swarangi, those who will be talking, they have to keep their cameras on.
Yeah. Yes. Me on karte.
And you can start.
Hello, everyone. Very good afternoon from all of us at Sathe College. We all are here today for our online workshop on demonstration of science toys, and it is conducted by our guest Shivani Pethe ma'am. She is from Ayuka, and we all here from Sathe College are happy to have all of you here with us for today's workshop. Now I request my friend Shubham Kadam to welcome all of you here on behalf of Sathe College. Over to you, Shubham.
Thank you, Swarangi. First of all, I would like to welcome our respected principal, Dr. Madhav Rajwade sir, our vice principal and our HOD of physics department, Dr. Dattatreya Nerkar sir, and our other vice principal, Srimati Pramodini Sawant ma'am. And I'm extremely glad to welcome here Srimati Shivani Pethe ma'am, who will be guiding us through this entire session. And we are all extremely cheerful and curious to see the magic of science through your demonstrations. And I welcome all the HODs of their respective departments and teachers and all the non-teaching staff of Sathe College. And I also would like to welcome my colleagues who got this opportunity to actively take part in this online session, and all the viewers who will be joining us through the Zoom and YouTube. Thank you.
Thank you so much, Shubham, for such a warm welcome. And now I request HOD of our physics department, Dr. Dattatreya Nerkar sir, to address all of us here today. Sir, over to you.
Yes, thank you, Swarangi. Principal Dr. Rajwade sir, today's resource person, Ms. Shivani Pethe, head of the departments, and dear colleagues. Regular curriculum is definitely important and mandatory also. But for overall development and benefit of students and understanding of the subject, some additional efforts like guest lectures, demonstrations, and field visits are also essential. In this direction, our college is always working, and under the guidance of our principal sir, some definite program is chalked out at our Sathe College. As a part of this program, today, Ms. Shivani Pethe is going to conduct workshop on science toys. I'm very sure you will enjoy this workshop. We all are eager for that. So without wasting any time, we are going towards the workshop. So I'm handing over to Ms. Swarangi for the next announcement. Thank you very much.
Thank you so much, sir, for sharing your thoughts with us. And now I request our principal, Dr. Madhav Rajwade sir, to address us today for this workshop. Please, sir.
Of course, thank you. I am quite eager to listen to our presenter today, Ms. Pethe, and from Ayuka. This is going to be a very good joyride to everyone. I think it has been amply made clear by my colleague, Professor Nedkar, that how we want to strive to see that our students see the other side of the subject, because subject at times can become, though it is not intended, can become a core. Means for students and teachers, both of them, it might so appear that this is a thing to be done on a laundry list of things to be done in a day. Like you come in the morning, you finish this off, then you go home and all that. So instead of that, it is actually an enjoyment to carry forward to in your entire life, not just the subject, but in the life itself. And when we are talking about scientific toys and their workshop, toys is something which we leave behind in our childhood. I'm not making it up, but I'm telling you for a fact that I knew of a person, a grown-up individual for that matter, had a storehouse of toys for himself in his cupboard at home, and he would at times take them out. He used to stay in Goregaon. He was a friend of friends. So that just shows that the kind of a child which resides in a man or a woman should remain alive all throughout our lives. And I think today we are probably precisely going to do that. Because if you have these toys to which science is attached or in a way associated, if you really understand those reasonings behind that, I think the job is done. The job of education, the job of enjoyment, job of doing with hands. Right now, there is an emphasis, a lot of it, on doing things with your own hand. So I think everything is done. I quite want to commend my departmental colleagues. Incidentally, I belong to subject of Department of Physics, though I'm a principal, but I do belong to some subject, and that happens to be physics. Quite happy to note that such a meaningful program was conceived by my department in line with the other departments. Every department has been doing this, but this is one in line with the others, but a very meaningful one, useful one for students. And I hope they take some lesson out of it and try and do it themselves. Welcome, madam, to Sate College, though in an online mode.
Thank you, sir.
One more thing, that this particular thing we are about to do would come alive like in an auditorium. म्हणजे थोडक्यात असं सांगायचं आहे की जादूचे प्रयोग ऑनलाईन करणं कठीण गोष्ट असते.
खूप कठीण आहे.
ती ह्या मॅडम करणार आहेत आणि तुम्ही सगळे पण ते करणार आहात. याच्यावर केवळ एक कृपा ह्या ऑनलाईन माध्यमाची आहे. मला असं वाटतं की त्याचं मजा आपण घेऊया. मी सुद्धा माझ्या टेबलवर जी सगळी कामं आहेत ती बाजूला ठेवली तास तसं करता अधिक वेळ थांबणार आहे आज, पण आज हे पूर्ण वर्कशॉप मला पाहायचं आहे आणि जास्ती वेळ न घालवता मी थांबतो इथे. सरांगी, बॅक टू यू.
Thank you so much, sir. Now it is time to start the workshop. But before that, we all want Malvika Naik to introduce us to our today's guest, Shivani Pethe ma'am. So Malvika, I request you, please give us a wonderful introduction for such a wonderful guest.
Yeah, thank you so, Sarangi. Am I audible? Okay.
Yes, you are.
It is my utmost privilege to introduce our today's guest of honor, Srimati Shivani Pete Madam, as she is a woman of many attributes. She is a science content developer and she emphasizing on learning science without making it cumbersome and boring. She is currently the project assistant at IUCA, that is Inter-University Center for Astronomy and Astrophysics, since June 2018. She has completed her bachelor's degree in physics from Fergusson College and her master's in nanotechnology from Savitribai Phule, Pune University. She is currently also an intern for a project with IIT Delhi. She was India International Science Festival IISF 2016 expert and has also given a talk on developing low-cost science laboratories in schools. Teachers across India attended the talk. She is also the recipient of Swami Vivekanand Yuva Puraskar and felicitation of women innovators. She has traveled throughout India, especially to Northeast India, in her efforts to aid scientific studies efficiently by conducting students' workshops covering about 2,500 students, teachers' training programs on learning science through toys, development of scientific educational resources, and setting up science laboratories for schools from 5th to 8th standard. Her inspiration to do so was from her self-experience of science becoming cumbersome due to giving various entrance exams for her PhD, which led her to be the founder of Wonderlab, that is Wonderland of Toys, since July 2016, in which they promote studying science via simple toys and learning the scientific principles from those toys. To give us a taste of the same, that is how science can be made fun, she is here with us today. Let us all give her a virtual round of applause. Thank you.
Thank you so much, Malvika. And
Thank you.
after this, nobody wants
Swarangi,
to...
your voice is very low. Please use off your mic.
Okay. I hope I'm audible now. So after this introduction, I'm excited for this workshop. So without any delay now, let us start it. So I request Shivani Pethe ma'am to take over the meeting and...
Yes. Am I audible?
Yes.
Good afternoon. And as this is an online session, I am really bound to this space. Otherwise, in my session, I use the whole stage. So I hope you are able to see my workspace. That is more important. And if you're not able to see me, that's completely fine. But I hope my workspace is visible properly. So I'll be doing stuff here. So there is a lot of stuff here and here, which I'll be using, which you could have seen if it was offline, and the excitement level goes a little bit up by looking at all these stuff. But unfortunately, you're not able to see it, but it's okay. You'll get to see it one by one. So I hope English is okay. If I should go in Marathi, Hindi, anything is fine. English is fine? Okay.
English is fine.
Yeah, that is completely fine. So to start with, I never use PPTs in my session, but again, unfortunately, I have to do that to bring a bit visual appealing things in my session for the visual audience that I have. For the auditory audience, I'll be using some stuff to create different sound, and my voice modulation is pretty good. And for the kinesthetic audience, I'll make sure you can do all this stuff at home. And the material that I use is really, really low cost, and you can get it at home, and everything for sure is under $10. So that's very interesting stuff, and let's begin. So I'll share my screen. I hope that is visible. You can just give me a quick feedback.
Yeah, it is visible.
Yeah, a PPT named Science Toys in blue color, because I'm not able to see it myself.
Yeah, it is there. It is.
Okay. Yeah. To start with, I will encourage you people to not participate in this session like a lecture. So please, everyone, feel free to keep your videos on, to keep your audios on. So please do not mute yourself in every lecture. Before this, you must be getting instructions to mute yourself, to keep your videos off. But please, in my session, please keep your audios on. Talk to me whenever you like. You can interrupt me anywhere in between the session. You can discuss things in between yourself, so that I can stop talking and you can go on interacting between your friends too. That can also help a lot. So I'm okay with any of these, and you can cut me in between my sentence also. That is fine. So going forward to my sessions, and I encourage you, please ask questions. Please answer the questions that I will ask. So let this be an interactive session, and answers can be wrong. And I think answers, if there are 10 answers, not all answers are right, but you can please answer whatever I ask, because that is how we are going to reach the final correct answer. And this is not a lecture. I'm not going to teach you anything. I'm just going to tell you a way in which you yourself can learn to reach the answer in your life. So this is going to be a journey. If you follow me, come with me, you will reach the end. Please do. So introduction of science toys is very easy. It is science and fun that goes hand in hand. And as the principal sir said, that we should not detach ourselves with science, and that is the exact same thing that I want to tell you today. So we'll be covering why is it necessary, why science toys are necessary, how to make these toys, how to make some space toys. I'm going to tell you how to make some space toys. Then how can we, if there are some teachers attending today's lecture, I'll be covering how we can use these to teach in our classrooms also. Yeah, so accompanying this session with a really nice quote by Dr. Pratap Rai Chaudhary. So is a nice small story. I was assisting a group of kids in HBCSE in Mumbai. Those all were Olympiad kids, and they had an experimental lecture. So if you will be really astonished or surprised to know that these Olympiad kids perform many experiments mentally. So they don't even touch the apparatus. They can do, like, I'm also surprised how these kids can do all these experiments in their mind itself, and they come up with brilliant and correct answers. But he said that experimental physics is equally important, because there is a term called errors, human errors. Then there'll be some machine errors, some systematic errors, which are very difficult to predict, systematic errors. But so he had this quote in his lecture for all these kids, which said, when a child is taken away from toys, he or she is detached from science. So this is said by Dr. Pratap Rai Chaudhary. He is himself an experimental physicist in TIFR. So I don't know if he's still there, but he was there 2 to 3 years back. So when he said that, something flashed in front of my eyes. Again, a short story I would like to tell. And if you all also have observed this in your surroundings, की कुठलीही आई आपल्या 1 ते 2 वर्षाच्या मुलापर्यंतच्या मुलाला घेऊन बाहेर फिरायला गेली, तर तिच्या पर्स मध्ये किंवा तिच्या बॅग मध्ये एक तरी खेळणं नक्की असतं. If the kid starts crying, if he starts annoying her, what she does is takes the toy out of her bag and gives it to the kid. But this stops, I don't know why, after the kid turns 2 or the kid starts going to school. Why does this stop? And then the teachers and the parents are so called like, this is your study time and please don't play around. This is your play time and now you can play. So the kids, when they go in school, we teach them, okay, this is what you play with, this is what you study with, this is the time that you play in, and this is the time that you study in. So 2-3-4 वर्षाच्या मुलांचा दोष नाहीये, हा बऱ्यापैकी पालकांचा आणि आपला दोष आहे, की आपण त्यांना हे सांगितलंय की ओके ही खेळणी आहे, त्यांनी आता अभ्यास करायची वेळ नाही, याच्याशी आता खेळायचं नाही. So he was the one who made me realize that okay, when a child is taken away from toys, he or she is detached from science. प्रिन्सिपल सरांनी आता ज्या माणसाचं नाव घेतलं त्यांना मला भेटायला नक्की आवडेल, ज्यांच्याकडे एवढा खेळण्यांचा स्टॉक आहे. So I'll ask for it afterwards, its address. Okay. Okay, so now we are going to start with our experimental stuff. And my first set of experiments is with candles. So I'll stop sharing my screen. I'll share it again when I need it. Okay, so a candle, hardly 2 rupees, 3 rupees, maximum 10 rupees if you buy a fancy heart shape blah 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 candle. But yes, I have a 2 rupee candle with me, and I'm going to place that candle here, and I'm going to light this candle up. So is everyone able to see the flame properly? Please, anyone can unmute and let me know.
Yes.
Okay, so this is a very, very, very typical, very काय म्हणतात त्याला खूप नॉर्मल आणि नेहमी सगळ्यांनी करून बघितलेला एक्सपेरिमेंट किंवा खेळ असणार आहे. What will happen if I place a glass on this candle? पटपट पटपट सगळ्यांनी अनम्यूट करून पटपट उत्तर देऊ शकता. ओव्हरलॅप झालं तरी काही हरकत नाही.
विजून जाईल थोड्या वेळाने विजून जाईल.
ओके, सो हे तुम्ही करून बघितलंय का पुस्तकात वाचून सांगितलंय?
करून बघितलंय.
व्हेरी गुड. सो आपण हे करून बघूया. सो मी आता या कॅन्डलवर एक ग्लास ठेवला आहे आणि होपफुली ती कॅन्डल एक्सटिंग्विश होईल. लेट्स सी. And done. So you can see we don't need even 2 to 3 seconds to experience something किंवा काहीतरी करून बघायला फार वेळ लागत नाही. So what is happening? Why is the candle getting extinguished?
You're cutting the oxygen supply.
Okay. Okay. So let me. So आपण ऑक्सिजन देऊया ना त्याला. हवेचा प्रवाह जो आपण कट करतोय ते खाली बंद करून टाकतोय. सो बाहेरची हवा आत जाऊ शकत नाहीये. सो लेट सी. आपण एक जागा तयार करूया छोटीशी. म्हणजे हा मी ग्लास असा ठेवते. दिसतंय ना हे? सो इथे गॅप तयार झालेली आहे. इफ यू कॅन सी. And hopefully now the candle will not extinguish. Let's see. काय वाटतं तुम्हाला काय होईल? मी तुमच्याकडे बघत नसले तरी उत्तर द्या. प्रश्न ऐकू आला तर काय होईल? इथे मी कॅन्डल मध्ये ठेवली आहे. आता मी वर ग्लास ठेवल्यावर काय होईल? Okay, what will happen when I place a glass on top of these bottle caps? आता इंग्लिश पण हिंदीत पण सांगू विचारू का? हिंदी
परत वेझल because the amount of carbon dioxide inside the glass will increase and like the flame won't get enough oxygen and it will extinguish.
पण आपण जागा ठेवणार आहोत ना एअर सर्क्युलेशन व्हेंटिलेशन साठी.
हो, but I feel like that.
Feel, okay. Feeling is nice. You can feel answers and write.
No, not really feel, but like
have you? I'm sorry. I cannot really see every one of you on the screen. So can anyone tell me who is talking?
Jugat Sringare.
Okay. Hello. And can you explain your feeling?
Like I said, it's not really a feeling, but like the carbon dioxide which is produced because of the combustion, it has nowhere to go inside the like.
That only I'm saying. No, I'm letting it go. I have created a slit for it.
But
but it will not go from there. Is that what you want to say?
Because
Why?
that's the way
something works.
No, no, no.
Then
It will be hotter, so it will go up. And since it goes up, it will have nowhere to escape from the
nowhere to escape. Okay. Okay. Yeah, so this is the answer. So okay, let's see. तू हे करून बघितलंस का गार्गी?
No, ma'am.
Then how can you be sure? And what if the candle does not extinguish now?
मी स्वतः नाही केलंय, but केलेलं बघितलंय.
ओके. कोणीतरी किती पार्टिसिपेंट्स आहेत? कोणीतरी स्वतः करून बघितलंय का? मला दिसत नाही किती पार्टिसिपेंट. ओके. No one has done it before. Okay, so this is the first time. Again, you have to watch it. So it would be really nice if you can do it on your own. किती काय लागतं? एक ग्लास. I'm sure सगळ्यांकडे असणार. एक कॅन्डल आणि I'm sure सगळ्यांकडे असणार आणि एक आगपेटी. सो हे किती अवघड आहे करायला. आणि तुमच्याकडे बाटलीची कॅप नसतील तर काही वापरू शकता. मी मॅग्नेट्स वापरते अधनं-मधनं. स्पेसर म्हणून वॉशर्स वापरू शकता. आगपेटी सुद्धा वापरू शकता. 2 आगपेट्या. सो आय विश सगळे हे करून बघतील घरच्या घरी. ही आधीच छोटी आहे. कोणी हे पॉइंट आउट नाही केलं, हे आधीच छोटी आहे, मग ही विजली तर तुम्ही. ओके. सो लेट्स स्टार्ट. 1 2 3 गो. उत्सुकता वाटते का काय होईल? ऑलरेडी माहिती असलेली गोष्ट सुद्धा बघायला उत्सुकता वाटते ना. So yes, rightly said, it will extinguish. What if I hold this glass like this? एवढी जागा दिली आता. आता काय होईल? गार्गी?
आय थिंक त्याला जाईलच, बट त्याला जास्त वेळ लाइटेड राहील.
ओके. सो जास्त. सो जास्त म्हणजे काय? किती? सायंटिफिक भाषेत तू उत्तर जास्त आणि कमीत नाही देऊ शकत ना. सो दिस इज वन थिंग यू ऑल आर गोइंग टू ट्राय इट ॲट होम. पण आता मला जर ही कॅन्डल, ओके ठीक आहे, उत्तर सांगायचंय नाही का. पण काय मी सांगितलेलं उत्तर बरोबर आहे की हवा, मी हा ग्लास मी ह्याच्यावर ठेवल्यावर द एअर इज गेटिंग हॉट इनसाइड अँड as it is getting hot, it is getting less dense, hence it is getting lighter, hence it is. बघा तुम्ही काय काय एका कॅन्डल आणि ग्लास मधून शिकू शकता. हॉट एअर एक्सपांड्स. हॉट एअर एक्सपांड झाल्यामुळे काय होतं? व्हॉल्यूम वाढतो. व्हॉल्यूम वाढल्यामुळे होतं डेन्सिटी कमी होते. डेन्सिटी कमी झाल्यामुळे काय होतं? इट ट्राईज टू गो अप दॅन द कोल्डर एअर. मग ती ऑलरेडी इथे आहे जमा झालेली, तिला बाहेर यायला खाली यावं लागेल, पण खाली ऑलरेडी एअर आहे. सो तिला बाहेर जायला जागा मिळाली तर दुसरी एअर ऑक्सिजन असलेली आत जाऊ शकेल. Am I making sense? This air has to come out of somewhere, then it will make space for the air outside with oxygen to go inside. But as it is hotter, it will not come down than the cold air. One more very simple experiment that you can do. When you are taking a bath, you have a mug and a bucket full of water, right? Invert your mug exactly 90 degrees and try to put it inside the bucket of water. Can you fill in water in the mug like this?
No.
Why not?
Because air already आतमध्ये.
Right, air already आतमध्ये. And if you exactly. So जरा tilt केल्यावर काय होईल?
बुडबुडे येतील, एअर बाहेर निघून जाईल.
आणि पाणी
आत जायला लागेल.
एक्झॅक्टली. सो लहान मुलांना हे शिकवलं जातं की एअर दिसत नाही, मग कसं तुम्हाला कळेल की एअर आहे की नाही. अँड देन you design experiments to show them that, and this is a very simple experiment that you can design to show every kid every morning when he takes a bath, you can do this, right? This is a very simple experiment that everyone can do at home, and this is also a very simple experiment everyone can do at home. So, आता मला काय करावं लागेल? What? Now this is something crazy, okay? का तुम्हाला हे करायचं असं वाटू शकतं? But I want to place something over this candle and keep it burning. What should I do? काही ठेवू नका ना.
Hole
ती
in
burn
that
हो.
glass.
Make a
Hole in that glass वरच्या साईडला किंवा साधारण वरच्या एरियामध्ये.
okay. So मग काय
So
होईल?
carbon dioxide or in short hot air can escape.
कार्बन डायऑक्साइड और इन शॉर्ट हॉट एअर नाही बरं का. कार्बन डायऑक्साइड ही खूप वेगळी गोष्ट आहे. हॉट एअर मध्ये नॉट नेसेसरीली फक्त कार्बन डायऑक्साइड असेल, पण ठीक आहे, लेट्स गो विथ द फ्लो. येस, हॉट एअर काय होईल?
एस्केप करेल.
आणि
And if we have some gap म्हणजे खालच्या साईडनी गॅप ठेवली आपण तर ऑक्सिजन पण आत येऊ शकतो.
हा, बऱ्याच कंडिशन्स आहेत. तर एक एक कंडिशन आपण करून बघूया. आता मी ग्लासला तर नाही भोग पाडू शकत, म्हणून माझ्याकडे इथे एक प्लॅस्टिकची बाटली आहे अर्धी कापलेली, ज्याला इथे होल आहे. दिसतंय? कॅन यू सी इट?
Yes.
No?
Yes, we can.
Yes.
Yes? No, I don't want to keep any ambiguities in my magic. Okay? There is a hole. Now, I will light my candle. Now it should keep burning, right?
No, because
But it is.
just carbon dioxide is escaping.
So how much time we should wait to know if it will go off or it will stay like this? जास्त वेळ, कमी वेळ? Yes, rightly said, it did extinguish. So, can you see that it extinguished? Why?
No fresh oxygen supply there.
Okay.
Yeah, just
So now, now
it will last a little longer.
But it will extinguish?
Let's see. I don't know.
What happened? We have oxygen now. I have done everything that you said. I have kept a slit for your fresh air.
मी करतोय मग.
I have a hole.
हे उद्याच्या नोटीसचं काय झालं? कोण काढतंय का?
काय झालं आता? Okay, this is not magic, okay?
चावी द्यायची
Probably of oxygen to the extent of the hotter gas.
Sorry?
Probably didn't get enough oxygen to keep it burning while the hot air was forming up there.
Okay, enough oxygen. Okay, again, what is enough?
Yeah.
1 kg is enough? 5 kgs? 1 gram? Again, one really, really important lesson. When you write answers of numerical questions, You forget to write units. 5, what? Apples, oranges, what? Your answer is 5. What 5? 5 grams, 5 kgs, what is enough? How much oxygen is enough for a candle to burn? How would you know? Okay, this is not enough. Then what? Should I make the hole bigger? Should I make the space bigger? Should I make the candle bigger? Should I make my flame bigger? Like what is enough? How will you know if it is enough? You keep experimenting, right? Don't you think this is the answer? You keep experimenting.
Yeah.
Now, this is a bigger hole than the previous one. Okay? And we'll make a bigger slit for the hole. What would you think will happen now? Everyone can see the candle, no? What will happen now?
I mean, it will keep on burning.
You will keep on burning. Now it is enough. Now oxygen.
थोडा जास्त वेळ फ्लेम राहील आपल्याला थोडासा जास्त वेळ मिळेल बिफोर
थोडा जास्त वेळ 1 तास 2 तास 5 तास 5 मिनिटं 3 सेकंद units
unless and until the oxygen inside it is enough.
Why do you people love these words? Enough, less, kami, jasta. If you have chosen a science stream, you should not answer like this.
There would be some proportions, right?
Yes. Someone's coming to the answer, yes.
Of the need for oxygen and the hot air. I mean, some comparison.
Yes. So now we come to know what ratios means. Why is it important to know about ratio? What is a ratio? And does a ratio have a unit? Is it same to any one quantity in the numerator, denominator, or it depends upon the both quantities, that is the numerator and the denominator? Okay, so why are scientific quantities in ratio also important as compared to the quantities that are in whole numbers? Mass, volume, acceleration. Mass, volume, density, right? So now you'll get an idea why is something which is derived has some unit which is as important as the units of these individual things. Am I making any sense, or it's like vague? Okay. Now let's see if it is enough. So now what the kids that come to Ayuka do are, when they come up to this activity, they just keep their candles burning and they say ki ताई आपण वेगळ्या activities करायला सुरुवात करूया, बघूया किती वेळ candle राहते. So they are really interested in actually taking a stopwatch, actually calculating some stuff, actually writing the observations, actually drawing graphs. And this is a really like amazing experiment. We have a paper on this experiment. If you would like, I would like to like share it with you. How much space, how much bigger hole, how much bigger candle, what happens to the hot air inside, what happens to the oxygen inside, what happens, how much carbon dioxide it is necessary to burn off something, right? These all numbers are very, very important. I have a fire extinguisher at my home, but I don't know if it is enough to extinguish some fire. So we cannot be vague. This will not help. Are you understanding the seriousness of units and numbers and derived units? If I ask you, if you are in an interview of a company that makes fire extinguishers. So for how much volume should I compress how much carbon dioxide, which will give me a capacity to blow out how much fire? Enough carbon dioxide. That will not help, right? But I just want to give you an idea of what enough is, what less is, what more is. And there is a really nice video I would like to share. If you want, you can mail me, I can share, which tells you what up and down is. What is up? What is down? It is all relative, right? So there's a nice video that tells you, but even being a scientific, even being a person from a scientific community, we tend to talk like this. एवढं द्या, एवढं चालेल. So एवढं म्हणजे काय? How would you know? So I think this candle is not extinguishing, right? So this much hole and this much space is enough, but we can go on calculating the ratios of the space and the diameter of the hole, and if it depends on the material of the thing that we are covering it with, and many more things. Okay. So I hope you understood some stuff from these candle activities, and if you have some questions, you can ask me before we move forward to our next session, next part. No questions? Okay. Can you see the screen? Yes. So now we are going to talk about some objects that float and some objects that sink. And as I've been told that you are senior college science students, I think these questions are very easy for you to answer. Can you see some questions on the screen? So why do objects float?
Ma'am, the relative density of an object is less than the, if we consider liquid, then it will float.
Okay, so some liquid, you're saying that the density of this liquid is XYZ, and the object that I will drop into this should have less density, more density relative to what?
Less density relative to liquid.
Okay, so then this ball has less density relative to the liquid is what you can say. Okay, what is our next question? Why do objects sink?
They are more dense.
Again, a very vague statement. More dense than the ball, than the water, than the glass, than the air outside the glass, then what?
The density of the thing that sinks would be more than the liquid that it is trying to dip inside.
Yes, very good. Now, does weight play any role in making the objects float or sink?
Ma'am, it's about the density only. If we just increase the volume, the weight doesn't play any role for that matter.
So weight will not play any role.
Weight will play partial role.
What do you like? Can you explain partial role? Weight.
As the formula for density is mass by volume.
Okay.
So if we increase the weight, keeping the volume same, mass will only affect the density. But if we are talking about whole density, then mass will be just partially responsible for its density, because even we have to consider the volume.
So now if I say there are two objects, both of 1 kg mass, very important, which one will float and which one will sink? Is this information enough to tell you which one will float and which one will sink?
No.
Why?
We need to know about their volumes, because without volume we cannot calculate density.
Okay. So then that is my question, does weight play any role in making the object float or sink? This is a yes or no question. It's not partially or whatever. Does weight play any role in making the object float or sink?
No, ma'am.
Okay, there's one answer and I think there are like 20 participants. Vote for yes. Vote for no. What are you voting for? How would I know? Shubha, say something. No, just this. How will I know?
No.
No, okay.
Yes.
Who says yes? Yes, weight plays a role. Okay. Sorry? Nota is not an option. Just yes or no. We have 1 yes, 1 no. Anyone else?
Yes.
2 yes. The people saying yes, can you please explain?
As explained earlier, it affects the density.
Mass, thank you. Mass affects the density, but I gave you okay, but
if the weight of an object is also making a force, right? And water is also applying an upward force, and if the weight of the object is more, then definitely the object will sink.
What is more? If the weight of the object is more, like there are ships, like tons of kilo ships who do not.
If the weight of the object is more than the buoyant force of water, then the object will sink.
If the weight of the object is
more than the buoyant force of water, then the object will sink.
Okay, so now we have a completely different definition for why does object float and why does object sink. So now you are saying that density doesn't play any role? Anyone?
Ma'am, the amount of volume inserted of an object inside the liquid determines the buoyant force. I know scientists had said eureka.
Archimedes, yeah.
Archimedes, yeah.
So what is Archimedes' principle now? Should we go into that or should we stick to Archimedean principle, objects that just float and sink, and just discuss about density, mass, and volume first. Archimedes principle, yes, we will if we have time, but I don't think we have time. But yeah, I would love to discuss these things. But the basic and the bottommost line is: have you thought about density, mass, volume, and why does object float and why does object sink in such deep sense before? Had you thought about it? Okay, answers please. We're wasting a lot of time just taking polls.
No, I guess like it's a normal routine like things.
So we don't think about it.
It just happens.
Okay, that's a nice answer. Okay, so what will happen if I put 100-gram stone and 100-gram of hollow plastic ball in water? Which one will float and which one will sink? Same weight.
Hollow plastic ball will float and stone will sink.
Why?
Because when we say 100-gram hollow plastic ball, it will have much larger volume compared to the volume of the stone.
Okay.
So density of stone will be greater than the density of hollow plastic ball.
Very
and
correct.
also
So did you realize that you considered the mass of the objects, then you considered the volume of the object, and then you considered the density of the object? Did you leave out something and consider the rest and gave your answer?
No, I considered all the things.
Yes. So considering all these things are very, very important, right? So then what is meant by density, and does it play a very important role in making the object sink and float? That we already discussed. Yes. And density is the amount of molecules that if it is densely packed, it is dense. If it is rarely packed, it is rarer than the substance in which the molecules are tightly packed. So yeah, so that is something really nice to think on. And then we have another toy or an experiment. What will happen? I hope you all can see the picture on the screen. Yes. So what will happen to the arrows when I fill the whole glass with water? What is this? What will happen to the arrows?
They will appear in directed in opposite direction.
They'll appear to be directed in the
Opposite direction.
why? Have you done this before?
I have seen it online.
This online stuff has made everyone lazy. You just see it and you don't do it on your own. So what all do you need to do this? Just a glass of water and water and a sheet of paper that has arrows. Can you see? Is it visible? So is this fascinating? So what is this? A convex lens or a concave lens?
Convex lens.
See different answers. Nice.
Convex, for sure.
Why?
It's bulging outside. That's the definition.
What will happen if I take a glass which is bulging inside? It is like a concave lens, and if I fill in water and if I look through it, if the glass is shaped like this, then what will happen?
Water acts as convex lens only, But if we fill water in concave lens, then we have to derive whole equation for that, because there will be two things. First of all, light is bending due to concave lens, and also the property of convex lens, which is due to water, even that will affect. So we
So
have
then
to
you're saying असा ग्लास असेल आणि आत पाणी असेल आणि आपण इकडनं बघतोय की इकडनं बघतोय.
म्हणजे लेन्स अशी असेल आणि आपण असं बघितलं तर लेन्सचा शेप विल अफेक्ट. बट असं बघितलं तर ओनली पाण्यामुळे परिणाम होईल. सो
ओनली कसं, तिकडे पण ग्लास आहेच ना कुठल्या तरी शेपचा.
शेप असा, ओके, स्टील शेप असा आहे. सो दिस विल,
the shape you're describing is these two sides. What about these two sides?
I guess they remain flat or same as it
So
is
we have
right
to
now.
design a glass now. Right? But yes, this is a convex lens, and you can see that what happens to the image behind it. But now, is this really acting like a mirror, or it is acting like a lens? Because in lens I have seen ulta image. Are you confused? Yes, you're confused already. Arey Baba, I'm holding it like this and this is happening this way. No, but in our class we like draw the object like this and get the image like this.
Yeah.
I'm just doing it this way. So it is not a mirror.
Yeah, it is a lens.
Then why did you get confused? Okay. So this is nice brain teasers. These are nice brain teasers. Okay, these are some very stupid guys. Okay. Now coming to this rocket, I want you to tell me what all forces are acting on this rocket once we make it. So let's start the video and let me show you how you can make it. So you can actually make this at home, okay? And like kids, like you also will enjoy a lot if there are teachers in your, or if you tend to be a teacher in your future, or if you want to be like volunteers for some workshops in the schools, you can make this toy and show it to them. We need a A4 sheet paper. You can use a used paper, that is fine. It need not to be like a very clear plain paper. Then you need a stiff straw. If you don't have a straw, like a stiff, we need a really nicely stiff straw like this. This is stiff straw, which will not bend easily. If you don't have this, you can use a PVC pipe, sorry, or a pen body. So what you do is you remove the front end, back end of the pen body and the refill, and then you can use that also. Then we need a bottle and some tinted paper. So now we are making a launcher, as you can see in the video. What you do is take the cap of the bottle and prick a hole inside the bottle cap, so that this straw or the pipe or the pen body that you're going to use fits really nicely in that hole. Okay, so go on increasing the diameter of the hole as you want till that straw or whatever you're using fits in it. And you have to make sure that you seal these ends really nicely, because why you have to do that is one question that you're going to answer. Seal the ends of the straw and the cap really nicely. And why we need to do that is one question, and like there'll be 3 to 4 questions before we end this video, then we can discuss further. Then we take a A4 paper and cut a small slit to make our rocket, and then we are making a small paper straw out of it and sealing all the ends, as you can see. And the next step is again important, and we are going to seal. Okay, make sure this slides nicely into the straw. Okay. And now we're going to seal one end of this straw with sellotape, like completely and nicely seal it. Again, why is a question. We are sealing this side. So just remember these questions. At the end of the toy, you will understand why I'm asking these questions and how to answer them. And I'm making small slits. And I'm sealing this end really nicely, okay? This end. I hope you are able to see the cursor and the pointer on the screen. Yes? You're not able to see the pointer on the screen? This one? Okay, yeah. And I'm sealing this side. So I'm again going to ask why. And then this is some stuff that you do to decorate the rocket. It's not very important. This is our rocket and this is our launcher and it's completely ready. But yeah, this is something that kids love. And as we do these workshops just to make toys and not to go in such deep science and discuss stuff that we are doing today, we do this stuff more with the kids, just decorating the rocket to make it look like a rocket. So there is a cap on top, and there are like, see, this is the cap of the rocket. And then there are like, these are the fins of the rocket, which I'm going to stick them on the bottom. So our rocket looks like a rocket, like this. And then we'll see how it's launched. So the rocket is ready. And I'm showing you the videos. I'll show you the videos 2 to 3 times. And then we're going to discuss the science and the principle behind this rocket. It's clear, right? Everyone can see the video nicely, right? You're able to figure out what is happening? Is this clear? Can we start discussing?
Yes, ma'am.
Yes, okay. Yes. So, yes. Can anyone tell me what is happening and why we are, like the questions that I asked, why we are sealing the cap and the pipe, and again, why we are sealing the end of the paper straw? And how is this rocket working? That's the main question. Is it that difficult?
We are sealing the pipe and the cap because of when we squeeze the bottle, it increases pressure, and we don't want air to go out from the gaps that is created by the hole that you made in the cap.
Yes. So increasing pressure of what, where, and how much?
Ma'am, I thought it is just for stabilizing the pipe, maybe.
Okay, this is one answer. Anyone else? Okay, you need to talk, otherwise this session will not proceed. One answer is to prevent air leakage. The second answer is to stabilize the straw. Anyone else wants to say anything else? No? Okay, so vote. Who thinks that we are sealing the ends to prevent air leakage, and who thinks we are sealing the edges to make it more stable? Option A, please vote for option A.
A, ma'am.
A, okay. Air leakage, okay. Now vote for stabilization of the rocket.
B.
Yes, ma'am. B.
1, 2, yes. Only 2 people. Sorry. Okay. So now the people who think why is it important to prevent air leakage, please explain. And the people who think why is it important for the straw to be stable, please explain.
So the bottle is acting as a launcher. So it's basically trying to give the whatever the air is within the bottle, it's giving a upthrust to it. So if the air there's air leakage, then there won't be any enough upthrust to it. So that's
Enough. Yes. The thrust should be enough to launch the rocket. Yes, right. The second answer, who is saying that to stabilize the straw. Can you please explain?
Ma'am, it's this like for giving a proper direction to the rocket. Direction is important.
What is proper?
The way that we want it to go.
How would you know what is the way that I want the rocket to go? Like I should seal it in a different way to go it, give it a different direction. And if you want to make it go in a different direction, you have to seal it in a different direction, different way. Is that what you want to say?
No, it's actually just we have to let it out straight now.
To let it out straight. Okay. Okay. So if we seal it nicely for stabilization and then we prick a small hole somewhere else in the bottle cap, what do you think? Will the rocket get launched? Like I have a bottle cap and I have nicely sealed the hole for the straw to be stable. And if I prick a small hole somewhere else, a very small hole, will the rocket get launched? Now my straw is nicely stable.
It will get launched, but it will go in a different direction. It won't go straight.
So you want to change your answer? I think you voted for A first.
No, if there are too many gaps, then there will be too much air leakage and it won't, the rocket won't be launched. But if we prick a hole in one side, then it will go on the other side.
But first you are saying if there are air leakages, the rocket will not get launched only. Now you are creating an air leakage and you are saying the rocket will go in a different direction.
No, only in a specific, in a, means if it shouldn't be, there shouldn't be too much air leakage, but if we make it in a in one spot only and control it properly, then it will.
How will you control air
not
coming
control,
out of the hole?
Control the air leakage to make it go in another direction.
Okay.
Ma'am, if there is a slight hole, very slight hole, and then as Surangi said, the upthrust should be needed to get the rocket going. But if there is a hole, the rocket would not go as much as far that it would have been gone. So it's slightly.
What is as much as far and what is enough again? And these things are very vague for me to understand.
It will just fall slightly short.
The rocket will not get launched only if you have even a pinpoint holes anywhere in the launcher. Now this is the answer, and now let's try to explore it. If you have even, if there is no hole, okay, imagine there is no hole, and if the bottle cap is slightly loose, not even completely open, if it is slightly loose, the rocket will not even, it will not get launched only, it will stay in its place. I can show you that happening. Have you heard about instantaneous force?
Yes.
What will happen if I press the bottle slowly, and what will happen if I press the bottle at an instant? So I've not sealed, okay? I've not sealed the straw. There is air leakage. Is my rocket launching a bit? Or as you say, there is no enough air thrust. You can see air coming out, and air will start leaking as the instant you start pressing the bottle. The pressure will not develop on you. If there is a small hole, the instant you start pressing, even if it is a small fraction of a second, you think it is enough for the air to leak, and the pressure will not develop for the rocket to get launched. So the bottle, the launcher, the straw, this end, everything should be airtight, completely airtight, and hence no sellotape or anything is done. We need araldite for that, as I have done here, and I have not done it in the video purposely. We need araldite to seal all these ends to make it airtight. Let it stay for one night. You can see bubbles in the araldite if there is some air leakage. Again, put some araldite on top, and you make it airtight, completely airtight. This hole should be completely airtight with this straw, and this paper ka slab should be completely airtight. No air leakage is allowed. Even a fraction of percent air leakage is not, does not help in launching the rocket. Okay, so instantaneous force is important, and preventing complete air leakage is very important. Okay. This is again my favorite topic and my favorite toy, and a very, very, very fascinating toy for everyone. Like, this is actually magic. Okay, so now I have a bottle, a very simple bottle like this, without a cap. I'm making a hole in this bottle, and the water is flowing out of the bottle, as you can see. Okay, now I have to do something for the water. Like, the water is there in the bottle, but it is not coming out of the hole. What things can you do?
By dropping the water, by dropping the bottle.
Dropping the bottle?
By dropping the bottle, the stream would stop falling from the bottle.
Okay.
Till it reached the ground.
So you think that there is a hole in the bottle, and there is water inside the bottle, and still the water will not come out of the hole?
Yes, as you drop, by the time it reached the ground, the stream of water flowing will stop.
Okay. Any more answers? Okay, this is the
परत
answer.
एकदा cap लावली जर बॉटलची,
Huh.
so water will stop coming out if we cap लावली आपण परत बॉटलची, तर
परत
होल
म्हणजे आधी काढायची.
पाणी घालायला काढलीच असेल ना आपण.
आणि मग
सो
मग नंतर होल
परत
पाडायचं
लावली.
की आधी होल पाडायचं?
जेव्हा आपल्याला पाणी थांबवायचंय, when we don't want water to flow out of that hole, आपण परत कॅप लावायची.
So there will exist a water bottle with a cap with a hole and water inside the bottle, and you say that the water will not come out of the bottle
if the cap is airtight.
So the bottle, okay, so the bottle has a hole and the water will not come out of the hole if the cap is airtight.
Yeah.
Okay. Any more answers? Any more answers? There are 2 ways have come up. Any more ways? Okay, everyone, can you at least hear that this is like, can you feel that this is crazy? Like, one person has suggested to drop the bottle. So the bottle is falling down, the bottle has water in it, the bottle has hole in it, and he thinks the water will not come out of the hole. The bottle is filled with water and the water will not come out of the hole. And there's one person saying that just keep the bottle like this and there is a hole in it, there is water filled in it, and just put the cap back and the water will come out of the hole. So you think these people are crazy, or like you think they are genius, or what do you think? If you have another answer, please let me know. Some other answers, please. At least one more answer.
Ma'am, are we going to drop the bottle from the height?
You can do anything. I'm not restricting you to do anything. You can do it. Drop it, break it, put the cap on, remove the cap, do whatever. You just have to stop the water from coming out of the hole. You don't have to block the hole, okay? Someone will say block the hole with.
Ma'am, I want to say about like place a finger over there.
Sorry?
Place a finger in the hole.
Yeah, that is what I said. There is a condition. We don't have to block the hole. The hole should be open, and yet the water should not come out of the hole. You can say this is impossible. That can be one answer.
And we can reduce the level of water.
Reduce the level of water. So here is the hole, and fill the bottle with water till here. See, now I like think there's at least one sensible person in the group. Yeah, very nice answer. Anyone else? See, now we have 3 answers. 1, fill the water below the level of the hole, and you have a hole, you have a bottle filled with water, and you have water not coming out of the hole. See? Anyone else? But yes, I'm very, very happy and very, very glad to announce that the first 2 options were also perfectly right. And these people are not crazy, and this does happen. And there are 2 different scientific reasons for these, and we're going to see both of them. Okay? So the first person, he said that drop the bottle from height, and the instance that you drop it from the hand, the water will stop coming out of the hole. So I don't believe anything anyone says till I do it. So I did this, and I got some results, and I shot these results. And obviously I was lucky to have a slow motion camera in my phone. Could you see the water stopped coming out of the hole the instant? So the water that you see here is the water that has already come out of the hole when the bottle was in my hand. But now if you crop the picture from here, from this drop, you can see a bottle, you can see water in it. The hole is not blocked, the bottle is completely open from top, and you can see the water has stopped coming out of the hole. Here you can see it again, the water is not coming out of the hole. Isn't this fascinating and magical? Yes? Is it? Yes or no?
Yes, ma'am. Very much.
Yes. So, really nice whoever answered this, but unfortunately now he has to answer why this happens. So, who answered this question? He must be thinking, why did I answer now? I have to tell why this is happening.
It is a free fall, right? So it's like if you can consider someone in elevator, so he won't experience gravitational force while in free fall. So water doesn't experience gravitational force while in falling.
So if water does not experience gravitational force, it should remain where it was. How is it falling down?
Because it's packed over.
No, I have not packed it. That is what I'm saying. The bottle का cap is open.
Cap is open.
तो ऊपर से बाहर आ सकता था.
But it's also falling, right? Water is also falling. But it is experiencing gravitational force is applying on it, but it's not experiencing because it has
Gravitational force is acting on it, but it is not experiencing. What is the state of gravity?
Ma'am,
like what happens in elevator, like if it's in free fall, we
did you experience any elevator in a free fall? Did you stand in the elevator and cut the ropes off, and have you done this experiment? I suggest please don't do it. But yes, you are coming closer to the answer, but you are not quite to the answer. Anyone else?
Ma'am, the reason when water was flowing in the first place, because when you were keeping the bottle in your hand, the pressure at every point it is equal. So the moment when you dropped it, at that time there was it was in the weightlessness state. So the pressure at every point, the pressure at the point where the water was coming out from the bottle is because of the weight of the water which was just above it. So now it is in the weightlessness stage. So there is at every point.
Which pressure are you talking about? The air pressure, the water pressure, the atmospheric pressure, or the pressure of the water on the bottle?
Water pressure, ma'am.
Water pressure on the bottle?
Yes, ma'am. The pressure at that level, which was due to the water above it. So now as it is in weightlessness state, there is no pressure buildup inside every point in the water. So now it wasn't flowing from the hole.
Okay, again, somewhat right answer, but not to the point. So, who was talking? I think his answer and Shubham's answer mix करके हम final answer तक पहुंच पाए. तो कोई try करेगा?
I mean ki bottle and water are falling with the same speed and acceleration. So
Yes, very correct and very true. And this is the right answer. And these words are very necessary. And I don't know why you forget to use them when you give a scientific answer. But yes, both are experiencing the same gravitational force and acceleration. Hence, they are falling in a weightlessness state. So I said both answers are right. So combine these two and you get the final answer. कि जब मैंने बॉटल पकड़ी हुई थी, मी जेव्हा बॉटलला पकडून ठेवलेलं तेव्हा I used some muscular force to prevent it to fall down, right? So how much was that force?
Equal to the weight of that bottle.
Again,
mg.
mg.
Partial answer, yes. So you said weight of the bottle, that is mg, right? So the gravitational acceleration will also be counted, right? So mass and the gravitational acceleration, जितकी वस्तू जड तितकं मला धरायला जास्त फोर्स राहावा लागेल, right? What happened when I released the bottle? Now the bottle is also experiencing G. The water inside is also experiencing G. जर ही पाण्याने भरलेली बाटली याला होल नसतो तर ते पाणी पण धरायला मला कष्ट पडले असते, बाटली पण धरायला कष्ट पडले असते. पण आता त्या बाटलीला होल आहे. So I lost the control over the water which is experiencing G. Are you understanding or I'm talking something? Can you please mute your mic if you're not talking? Someone's mic is unmuted. There is a lot of noise. Okay, I also got muted. Okay, so जेव्हा मी ही बाटली सोडते, when I leave this bottle, G acts on both at the same time. Hence, they start experiencing the weightlessness. Now, the water does not have to take much pain and more energy to come out of the hole because it is already going down with the bottle, right? So it is going to acquire the minimum energy configuration and it will not spend its more energy to come out of the hole because it is already going down with the bottle. Are you understanding? Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay, good. So this is a very, very, very interesting activity and I love this very much. This is again a very nice activity. But yeah, we'll move on to this activity. This is a very nice activity and I suggest everyone would do it with me because it is a very nice activity. So, can everyone take a page or a A4 sheet paper? Everyone knows how big is our solar system, and I promised that I will show you some space toys, and this is one of them. And you have everyone has an idea that solar system is very big and the planets are this much and this much XYZ astronomical units apart from each other. And you also know how big in size is our solar system, how big are our planets also. But have you tried to mimic something on a sheet of paper and get a feeling, get an idea of how big a solar system is? Has anyone done that before? Have you tried to scale down a solar system? Do you know what scaling down or scaling up is?
Yes, ma'am.
Okay, so have you tried scaling down a solar system before or any object before?
No, ma'am.
Have you
Not
seen it?
solar system,
Okay,
but I've
any
tried.
Which object have you tried?
Not, ma'am. I guess none.
Okay, so have you seen any scaled down miniatures to the scaled miniatures of any object or any?
I have done that before. I scaled down a house and a chimney for my project. It's been 2 to 3 years, but I have done that.
Wow, nice. So you did it by a ratio method
Yeah.
or unit method. There are two methods to scale down any system.
Ratio method.
Okay, so that was maybe 200 times smaller or 100 times smaller or 10 times smaller than the actual one. Is that what you did?
Yeah, it was 100 times smaller than the actual house, which I made.
That's nice. That's nice. Okay, so now we are going to scale down a solar system on this piece of paper. Okay, are you excited? I am. Okay, so this paper is approximately 29 centimeters, or if you have a bigger paper, it would be like 39 centimeters. I don't know why papers have this length, but they only have 30 or 40 centimeters long. But yeah, these are some units of A4 size or A3 size papers. Now, while scaling a solar system, we need to assume some things, obviously. So what we are going to do is we are going to take the astronomical units that are in a solar system to centimeters. Okay, we are going to keep the numbers same. For example, Neptune is like what? How much? Or Pluto is how much astronomical units away from us? Does anyone know that? No? Okay, so Pluto is, okay, so you could have Googled it right now. But yeah, Pluto is approximately, I'll say, 39.5 astronomical units apart from us. So for consideration and to make this activity a little simple, we'll say that the Pluto sits here, which is 39 centimeters away from the sun, and the sun sits on this top. So can you write with small handwriting in a pen, sun over here and Pluto over here in very small handwritings. And you can get your mobile or your calculator to calculate and divide and multiply and add distances. So sun and Pluto. And we are considering this paper. So you can have a smaller paper also, that is fine, because we're just considering the length. And we're considering this length to be 39 centimeters. Okay. Now what we're going to do is we're going to fold our paper in half, lengthwise. Okay. We're going to fold our paper in half. So now what is the distance that we have achieved? Just divide 39 by 2. Is that so much difficult?
14.5.
39?
39, sorry.
19.5.
Yeah.
19.5.
So what distance have we achieved? 19.5. Okay. So which planet would sit here approximately in between the solar system? Sun and Pluto के बीच में कौन सा planet होगा? Can you guess?
Jupiter.
Because it is the planet in between. Saturn, Jupiter. Any more guesses? Any more guesses?
Asteroid belt.
Asteroid belt. Okay. Nice. Any more guesses?
Uranus.
Perfectly guessed. So here is our Uranus at 19 astronomical units. This is 19.5. So you can maybe thoda sa upar you can write Uranus. So here is Pluto. 19.1 पे you have Uranus. तो कहीं यहाँ बीच में you will have Neptune at exactly 29.7. Okay, so write Pluto here, Uranus here. तो आधा सोलर सिस्टम तो ये 3 प्लैनेट्स ने खा लिया. तो पता नहीं हम कहाँ बैठेंगे, जगह है या नहीं हमारे लिए बैठने के लिए. तो here is Pluto, here is Sun, here is our Uranus. यहाँ बीच में कहीं 29.7 पे will be our Neptune. Now we are going to fold this paper again in half. Now, what is the distance that we have reached?
$9.75.
Yes. So what do you think? अभी Sun और Uranus के बीच में कौन होगा? Any guesses? At around 9.75.
Jupiter.
Okay. Any more guesses? सबको जुपिटर बहुत पसंद है क्या? यहाँ भी जुपिटर, यहाँ भी जुपिटर.
Saturn.
Yes. So now we have still reached Saturn. Imagine, अभी पता नहीं Mercury, Venus, Earth, Mars, Jupiter, asteroid belt पता नहीं कहाँ बैठेगा. So here is our Saturn at 9.5 astronomical units. So approximately 9.7. We have distance here 9.7. So the distance from Sun to Saturn is 9.5 astronomical units. So you can write Saturn over here. Now again we have to fold our paper in half till that space. Now what do we get?
4.
Distance?
4.75.
4.875.
Okay, approximately 4.8, 4.87. So we can say 4.9. So what do we have at 4.9? What do you think we have at 4.9? Again, Jupiter?
Jupiter.
Jupiter सबको 4%. Again, here you said Jupiter, here also you said Jupiter, here
Yes,
also you said
ma'am.
Jupiter.
Because, ma'am, maybe because, ma'am, Jupiter is protecting us from asteroids.
So it is your favorite. Okay, so any more guesses? Someone said Mercury. Sorry, someone
Mars.
said Mars. Okay. Someone said Mars.
Mercury. Yeah.
Someone said Jupiter. Someone said
I vote for Mercury.
you vote for Mercury. Okay. Anyone else?
Earth.
Earth. Okay. So ये पूरा astronomical unit का पूरा system ही collapse कर दिया. 4.8 पे Earth होगा तो. Okay. So I'll explain you what an astronomical unit is afterwards. So 4.8 पे क्या होगा?
Jupiter.
Yes. So whoever now your favorite planet is here, Jupiter, and it is approximately the distance is 5 astronomical units. So Jupiter is at 5 astronomical units from Sun. We still have to fit 4 planets in this space. See how far Pluto and Neptune and Uranus and Saturn are from us. Now we have reached Jupiter, and now we have to fold this again in half. I don't know my folding skills now. My folding skills are getting weaker now. Fold it in half. What do we reach?
Asteroid belt.
How much away? How much far is it? How much far have we reached?
Approximately 2.5 AU.
Yes, very good. So we have reached 2.4 AU astronomical unit, and our asteroid belt is 2.5 astronomical unit, 2 to 3 astronomical unit, because asteroid belt is not an object, it is a belt, and it is stretching along 2.5 astronomical units. Yeah, so we're going to write our asteroid belt. I don't know where we're going to fit our Mars, Earth, Mercury, and we consider ourselves so big. See how small we are. So that's our asteroid belt. We are again going to fold this in half. And where have we reached? Only this much space, okay, now we have. Where have we reached? 1.2.
Mercury.
Any more guesses?
Mars.
One is Earth.
Mars.
One is Earth.
One is
approach
Earth. Thank you. One is Earth, because that is the whole concept of this astronomical unit setup, and we're considering everything from Earth, or in comparison to Earth, or in comparison to where we are. Okay, so distances, units, हे सगळं कोणी ठरवलंय? आपणच व्हिज्युअलाइज करून, आपणच कन्सिडर करून ठरवलेल्या गोष्टी आहेत, राईट? सो आपण जेवढे सन पासून लांब आहोत त्याला आपण एक मानलं, आणि मग बाकीचे जेवढे लांब आहेत त्याला आपण काही फिगर्स दिल्या. सो आपण अजून 1.2 वर आहोत. सो आपण अजून मार्स वर आहोत, which is Mars is like 1.5 astronomical units away. I think everyone has started using Google now after so many wrong answers, but no, nevertheless you have started using it. That's a good point. So we are at Mars. We need to fold it again. I don't know where we will fit ourselves. Like Venus है बीच में, Mercury है, Sun को जगह चाहिए, and I'm like, I don't have any capacity to fold this paper now. I'm done. So can you all imagine? Did you get a gist of this idea? Like, this is the space where Earth, Venus, Mercury, Sun, everyone is sitting. This much space. We are so close to each other. Venus, Mercury, Mars, Earth, Sun, and Mars यही है, और मार्स पे जाने के लिए इतनी तकलीफ हुई, पता नहीं जुपिटर पे जाएंगे, यूरेनस पे जाएंगे, नेपच्यून, प्लूटो, सब बहुत दूर है हमसे. तो ये बहुत दूर, बहुत की आइडिया देने के लिए this was an activity to give you a glimpse or an idea of how far or how big or how our all planets are spaced. Okay, I hope you all have loved this activity. And again, the next activity that we're going to do is a paper folding activity. So I hope your origami is good enough. Okay, so now we're going to start folding our paper, and then I'm going to ask you several questions. Everyone be ready with one A4 size paper. Tell me how many times, like this is 1, this is 1, this is 2, this is 3. So how many times can you fold a paper? Okay, there is a very popular paper, like actual published paper on this activity. So this is a really nice activity. So anyone can tell me how much times can you fold a paper? Like what is the number of times that you actually can fold a paper?
7 or 8 times.
Okay, so have you actually done this, or you are? Yes.
Done in the school.
Yes, you can talk. Yeah.
Ma'am, I think if we take long enough paper, we can fold it any times we can.
Yeah. So no one thought that it depends on the length of the paper or the size of the paper?
I mean,
Yes,
depends on the
length
ratio.
and size.
Now you think that it depends on the length and size of the paper. So किती मोठा पेपर घेतल्यावर कितीदा fold करता येईल? Again numbers. But yes, A4 size paper के लिए whoever answered 7 to 8 times is correct. So I'm actually searching for the actual data so that I can give you exact numbers, because I have that data, and that data is really interesting. Till then, can anyone guess, and you can also Google, the thickness of A4 sheet paper so that we can go forward with our activity? एका A4 sheet paper चा thickness काय असतो? Anyone?
1 micrometer.
1 micrometer, is that what you're saying? Am I still in the meeting? Yeah.
Yes, here.
Yes. So I have got the numbers. 1 micrometer, is that what you're saying? That is 0 point, how much zeros and then 1?
I'm 10 power minus 6.
Okay. So that is like how much GSM? Any more answers?
90 GSM approximately paper.
That is how much mm?
I don't know in mm, but I guess it is 90 GSM. I read it somewhere. No, I don't remember exactly.
Okay. It's okay. It's okay. So can anyone Google it for me so that we can go forward in our activity? Anyone can Google the size?
0.1 mm. 0.1 millimeter.
0.1 mm.
Millimeter.
Yes, that is very correct. It is not micrometer. बहुत ही पतला हो जाएगा. It is 0.1 mm, and that is 0.001 centimeter, right? So 10 raised to minus 3 centimeters. So what will happen to the thickness of the paper when I fold it into half? These are like fast calculations now. What will happen to the paper when I fold it into half? What will be the thickness? Yes, so it will be 0.002 centimeters. What will happen when I fold it 3 times?
0.003 centimeter. Sorry.
Doubling it. Double.
Doubling.
0.004. Yes. What will happen when I fold it one more time? 0.008. What will happen when I fold it one more time? 0.16. Now we'll just scale it up and fold it 10 times. Fold the paper 10 times. What will be my thickness of the paper? Just get a calculator or a phone and do the fast calculations. Na? This is a fun activity. You'll
2
be
raised to the power 10.
Yes, so that is 1024, and multiplying with the thickness of the paper, that is 0.001, we get 1.024 centimeters, right? When we fold the paper 10 times, we get 1.024 centimeters. What will happen when we fold it for 17 times? 17. 2 raised to 17 into 0.001 centimeters, and we get 131.072 centimeters. What happens when we fold it for 25 centimeters? Are you understanding what we are doing? We are exponentially increasing the number. Do you understand what exponential increase is? 2 raised to 17, 2 raised to 25. What will happen if we fold it for 30 times? It is 10 lakh centimeters. That is 10 kilometers. What will happen if we fold it 40 times? 10 kilometers ही हुआ है अभी, 30 times fold किया है, 10 kilometers ही हुआ है. अभी सिर्फ 10 बार all fold करेंगे. And you will be surprised to know that we reach how much kilometers? Calculate it with me, no? We'll get a fun thing. 2 raised to 40 into 0.001. What do you get? 10,000 kilometers directly. And you'll be surprised to know we have reached the height of the GPS satellites that are flying on top of us just by folding the paper 40 times. And now we are folding the paper for 5 more times. That is 45 times, and we reach the moon. Can you imagine this? Just fold a piece of paper for 40 times, a paper 45 times, a paper of thickness 0.001 centimeters, that is this paper, and you reach the moon. Isn't this something very, very fascinating and very interesting?
Yes, ma'am.
And if we reach the moon, मैंने सिर्फ एक ही बार और fold करना है, and I reach back to earth.
Yes,
Are you
ma'am.
able to imagine it? Are you able to imagine it? मैं moon पे गई. This is the thickness of the paper now. I have to just fold it one more time, and I can come back to earth. Double हो गया ना distance? So that is the power of exponential increasing of any distance. And this is the very basic, or this is the only idea that was thought by a very famous scientist. I'll share the screen so that
Einstein.
you can see. Not really. Oh, sorry. I shared something. This was Giravli Observatory, by the way, which you saw right now on the screen. Can you see this?
Yes, ma'am.
So who was, we don't call Bill Gates the scientist, but he was, in my opinion. So in 1994, Bill Gates took this iconic photograph to show how the CD in his hands hold more information than all the paper below him. So he had that idea, कि इतना paper पे इतनी information, if we stack on papers and if we keep folding papers, if we reach this much distance, we can fit in way higher and bigger information on our CD drive. And this was obviously a picture taken by him. He could afford stacking all these papers and taking a picture. But yeah, this was something very fascinating that he did in 1994. So yes, so I hope all of you enjoyed today's session. And in this thank you slide also, this is one PSLV ka model that we have scaled down 200 times. So you can see the actual PSLV ka model, and this is the PSLV ka model we made with PVC pipes and magnets, which is exactly scaled 200 times smaller model. So I'll stop sharing my screen, and I think 5 minutes are left for question answers, and I'll thank all the organizers and the principal sir of Sati College and Sukruta ma'am and you all for participating really nicely. And thank you for inviting me, and from Ayuka also I thank you all. You can contact us anytime. You can visit when this COVID situations are a bit over. We welcome anyone and any day in Ayuka. And again, a big thank you to everyone. I hope you all enjoyed today's session. Thank you.
Thank you so much, ma'am, for such a wonderful session. We all enjoyed it a lot, and not just as a comparer here, but even as a physics student, I enjoyed it a lot. We learned a lot from it. And what we love is we love having fun with science and fun with physics. And that's what we did with you today. Thank you so much for such a wonderful time. And we do look forward to interact with you more, to get in touch. And I'm sure everyone will try these activities at home. And I would like to tell you, even my friends are doing it before this workshop was conducted, because we all read about your activities
Okay.
few days ago, and from Arvind Gupta sir's website and your
Yes.
videos, we all got inspired. And
Yes,
my friends have also created some things which they would like to show you.
Sure. We all are really
You were saying
inspired by
something.
Arvind Gupta sir.
You were
So,
saying something.
yes, I was saying the same thing, that we all are inspired by Arvind Gupta sir, and we are really fortunate in Ayuka that we get to work in the same room and we get to sit at the same place where he did and perform the activities. So we are very fortunate that we get to work here at Ayuka and sit in the same room as he did. So yeah, we all are really inspired by his work.
And we are inspired by you now. So my friends would like to present what they have
yes.
made.
Yes.
So Malvika, over to you.
Yes, thank you, Swarangi. So I've made a simple, like a flip it book showing the phases of moon. But it is really fascinating because, like, just I'll explain a bit, because we had thought we'll show the toys and we'll also tell what we understood from the toys or what we read. So, like, basically, a flip it book is, a kinograph in which the pictures are drawn gradually, with gradual changes, not extreme changes, so that you can actually see things in motion or they are changing. So I tried to make it in the phases of moon, and I'll see if you. I don't know if you can see it. Like if you can actually see it. I don't know. You can.
Yes, I can.
The phases of moon changing.
Oh, that's nice. So that's persistence of vision. You can again learn light lesson from that. Yeah.
Before we can actually, detect any images, the next image appears. So
Yeah. So your brain cannot register that less time, and so that's persistence of vision. Yes. Really nice.
Sarangi, I'm done.
Thank you, Malvika. Again, just like I said, it was such a wonderful session for all of us. We are really glad to have you here, ma'am, with us. And we would like to get inspired by this workshop. We would like to take this forward, interact with you. But as today, we have time limit.
I know we have time
um,
limit. I had so many toys. If you could have seen, I skipped many slides in between as we have a time constraint. But yeah, it was a good session. Thank you, Swarangi.
We look forward to meet you, to get in touch with you, and we will
Sure.
surely visit
Anytime.
Ayuka. Me and my colleagues will surely visit you.
Yes.
And we would like to take this forward even for next generation to work on this. But as we all know, there is a time limit, and we are moving towards the end of this wonderful session. So for thanking you all for working very hard, and to thank our resource person Shivani Pethe ma'am, I request my friend Shreya to take over. And
Okay.
Shreya.
Thank you, Swarangi. Good evening once again, everyone. On behalf of Department of Physics of Sate College, I would like to take this opportunity to propose the vote of thanks. In the beginning, I express my sincere gratitude to our guest of honor, Srimati Shivani Pethe Madam, for accepting the invitation and taking your precious time out from your busy schedule to provide our students this interesting and realistic information that how science can be made interesting with the material available at home, and to learn science behind these small things. We really enjoyed your session and got to learn so many things today, ma'am. I'm thankful to our principal, Dr. Rajwade sir, Vice Principal Srimati Sawan Madam, and Professor Dr. D.M. Nirkar sir for continuously guiding and supporting us with all the resources for the betterment of our future. I would like to extend my gratitude to our today's guiding and organizing team. My heartful thanks to all our non-teaching and teaching staff, my fellow classmates, and YouTube viewers for joining us with today. The workshop would not be any successful without you. Thank you, everyone.
Yes, thank you. Sir, shall we call off the program? Nirkar sir.